Now here the question is, let a1 equals 1 and an equals n into an-1 plus 1 for n equals 2, 3, 4. Define Pn as 1 plus 1 upon a1 into 1 plus 1 upon a2 up to 1 plus 1 upon an. Then we need to find this limit n tends to infinite Pn. Now we can write this Pn as a1 plus 1 upon a1, a2 plus 1 upon a2, and in the same way it goes up to an plus 1 upon an. Now from this recurring relation we can say that an minus 1 plus 1 upon an, it is equal to 1 upon n. So we can write this as 1 upon a1 and then a1 plus 1 upon a2 into a2 plus 1 upon a3, and it goes all the way up to an minus 1 plus 1 upon an into an plus 1. Now this is 1 by 2, this is 1 by 3, and this is 1 by n. So we can write this as 1 upon factorial n an plus 1 upon a1. Now we are also given that a1 is 1. So we can write this as 1 plus an upon factorial n. Now this is 1 upon factorial n plus an upon factorial n. Now an upon n is an minus 1 plus 1. So we can write an upon n as 1 plus an minus 1. So we can also write this as 1 upon factorial n plus, and this is 1 plus an minus 1 upon factorial n minus 1, which is 1 upon factorial n plus 1 upon factorial n minus 1. Now if we continue in the same fashion, in the end we'll get 1 upon factorial n plus 1 upon factorial n minus 1 plus a2 upon factorial 2. We can also write this as 1 upon factorial n plus 1 upon factorial n minus 1, 1 upon factorial 2 plus, now a2 upon 2 is 1 plus a1 and a1 is 1. So it will be 1 plus 1 upon 1. So that's your Pn. Now if we take this limit n tends to infinite Pn, it will be 1 plus 1 upon factorial 1 plus 1 upon factorial 2, and this series it goes all the way up to infinite. It is nothing but e. So the value of this limit n tends to infinite Pn, it will be simply e, and that's your option B.